Have you ever wondered how your air conditioner keeps your room cool on a hot day? It's not magic, it's science. In this video, we'll break down exactly how air conditioners work to make your space feel comfortable. An air conditioning system has two main parts, the indoor unit and the outdoor unit. Inside, there are two coils connected by pipes, and the refrigerant, Freon, flows through these pipes. But why do we use Freon as the refrigerant? Well, Freon has a very low boiling point, which allows it to change from a liquid to a gas and back again very easily. This is crucial to the cooling process. So, how does this process actually cool your room? Let's dive in. To understand how air conditioning works, we need to talk about two key components, the compressor and the expansion valve. The expansion valve does something very important. It reduces the pressure of the refrigerant. When the pressure decreases, the temperature also drops. This is called the Joule-Thomson effect. After passing through the expansion valve, the refrigerant's temperature drops depending on the system's pressure and other factors. At this point, the refrigerant is very cold and flows into the indoor unit coil, called the evaporator coil. Now, the refrigerant is colder than the air in your room, so heat from the room naturally flows into the refrigerant, just like how heat flows from a warm object to a cold one. This process is governed by the law of thermal conduction. As the refrigerant absorbs the heat, it cools the air in your room. Imagine it like this: when you place an ice cube in a warm drink, the heat from the drink flows into the ice cube, making the drink cooler. As the refrigerant absorbs all that heat from your room, its temperature rises. Now, the refrigerant needs to be outside to release the heat it has collected. This is where the compressor comes in. The compressor works like a pump, it squeezes the refrigerant, increasing its pressure and, as a result, its temperature. This is a thermodynamic principle: when the pressure of a gas increases, its temperature increases as well. Scroll compressors are widely used in modern air conditioners, and for good reason. Unlike older piston compressors that rely on many moving parts, scroll compressors use two spiral-shaped scrolls to compress the refrigerant smoothly and efficiently. This design has several advantages. It's quieter, because there's less vibration. It's more reliable, with fewer parts that can wear out. And most importantly, it's more energy efficient, helping reduce electricity bills and carbon emissions. After passing through the compressor, the refrigerant's temperature climbs to about 80 degrees Celsius. Now, it's hot and ready to release all that heat outside. The hot refrigerant flows into the outdoor unit coil, called the condenser coil. Here, the refrigerant is in contact with the outside air, which is cooler than the refrigerant. The heat naturally flows from the refrigerant into the surrounding air, just like how heat flows from a hot object to a cooler one. As the refrigerant cools down, it condenses back into a liquid. This cooled refrigerant then flows back to the indoor unit to start the cycle over again. The heat absorbed from your room is now safely released outside, and the cooling process continues. So, in simple terms, your air conditioner works by circulating refrigerant through the coils. The refrigerant absorbs heat from the air in your room and releases it outside, cooling your room in the process. The compressor and expansion valve play crucial roles in making this process efficient, keeping your space cool and comfortable. If you found this explanation helpful, don't forget to like and subscribe for more videos on how everyday technology works. Thanks for watching, and stay cool.